Okay, so let's start. I don't want to see my solution. Okay, sure. So let me open my PDF. Just a second. Okay. So these all are this theoretical question that we can take like after all these numericals if there is any doubt in this. So let's go to our first numerical and luckily or you can say fortunately there were like less number of you can say numericals, but the theoretical question is MSQs were deadly and confusing also. What is true for this? What is true for this? Okay, one algorithm questions. Question number 15. Okay,
Six,
this 16.
six was also there. Acha, that is also theoretical only.
So okay, this is like we need to use the formula, but I guess I missed this. I missed this in the solution maybe. Let's see. We can solve this like right now, no problem at all. I missed that completely. So what they are saying is 100 are positive and 300 are the negative points in the data set. So total points we have 400 and actual positives are 100 and actual negatives are 300. So this is ground truth. And now they are saying is and say we have two models M1 and M2. Model M1 predicts just 2 points as positive and one of them is correct prediction. Right, so what model 1 is doing, out of this 100 actual positive, out of this 100 actual positive, it is predicting one is positive, sorry, two of them is positive and one of them is correctly positive. So it was 1 and it was predicted 1, so it is just 1 point. Right, so this is nothing but 100 actual positives we have, right? And another, it is saying it's positive but it is actually negative, right? So only one of them is correct prediction, correct? So one is wrong, so it will come here. So it is actual negative but it is saying positive, right? False positive basically. Model M2 predicts the entire data set is positive, right? So what M1 is saying, just 2 points is positive, just two is positive. So rest all 398 point it is saying negative, correct? So 2 is positive, so 2 comes here, and for negative points 398 are say it is saying negative. So out of this 398, one was you can say out of this point 398, how many would be like a negative? All negative would be covered. I have 300 negative points, and it is saying like all 398 is negative. Rest 398 are negative, right? But this one point that was actually a negative, but it is saying positive. So I am making one mistake here. Out of 300, I am making one mistake here. So rest 299 point are correctly classified. Correct. Now how many are left out of this 319 and 299? How many are left out of how many are left out of this 100? I am predicting one. So here it would be nothing but 99 only. Right. So this would be nothing but the confusion matrix for model M1. Any doubt, guys? So 100 are positive, 2 it is saying 2 is positive and rest are negative. So one is correct and one is incorrect. So one is correct, one is incorrect. Now out of this 300, I am making one mistake. So rest all, like I am saying negative. So 299 are nothing but my true negative. So how much are left? So out of 100, I am saying one positive, correctly classified. So rest of all are nothing but the incorrectly classified. So false negatives, right? So this is for M1. Now I can make this thing. Actually we can answer this precision recall directly, but better to practice right now to create the confusion matrix, so that if they ask for any damn thing, 2 TNR FNR recall anything, right? Precision, we can answer that. So model M2 predicts the entire data set as positive. So what it is saying is like for every point, all 400 point I'm saying is positive, all positive, no negative value, right? So here it would be 0 0, simple. All I'm saying is positive. So out of 400, my 100 are correct, 100 positive points are covered. Now all these 300 points would be incorrectly classified. 300 are negative but I am saying is positive, so it would be nothing but my false positives. Now we can answer like any question. Precision of M1 is 0.5. So what is the precision? So it is saying like 2 positive, out of that one is only correct. So precision is nothing but I asking model like how precise you are. So if it is saying two are cancerous, but the precision is nothing but just one is the correct one. So 1 divided by 2.5. So A is correct. Recall of M2 is 1. So what is recall? So how many point you are able to recall basically out of the data set, out of all the positive points. So 100 are positive points and I am able to get each 100 at every point, every positive point I am able to predict. So 100 divided by 100 is nothing but 1 or 100% recall, you can say. Now, what is option C? Recall of M2 is 0.33. So what is recall of M2? So out of 100, I am able to get only 1 point, right? So 1 divided by 100 is nothing but 0.01. So option C is incorrect. Precision of M1 is 1. So what is the precision? Precision is nothing but out of total predicted positive. So I am predicting like 400 points as positive. But the precision is nothing but 100. And how many are true positive? That means actually it was positive 100 only. So 100 divided by 400, it would be nothing but 0.25. So C and D are incorrect, right? So the idea, or you can say the whole work, whole you can say hard work is to create this kind of what you call this confusion matrix, right? And don't get like to not get confused by while creating this. Okay, we can directly actually answer because they are just asking for precision and recall, and they have given data with respect to positive points. So directly we can answer, but just practice it once. All right. Any questions, guys? I just missed that.
Good, good, Mayur, go ahead.
Sure, sure. Next one. Yes. Given the actual labels and the predicted label of a classification models on below, which of the following options is correct? So again, we need to create the confusion matrix, nothing else. But if they give 1 and 0, it's really easy to create the confusion matrix, right? You can directly do something like this. So this is my nothing but actual value. In course video, I guess they write predicted value here, but in scikit-learn, it is actual versus predicted. Predicted is here, right? So see one and it is saying one. So one, how many we have? One, two, three, right? So you can directly write three. So this is nothing but true positive. The actual value was true, and I'm saying true. So true positives. One and zero. How many we have? One, zero, one, zero, one, zero. So again three, right? Zero and it I'm saying one. So zero, one I don't have, and zero, zero. One, two, three, four. Right, so chances are then thus. So 10 do we have? 3 plus 3 plus 4. Yes, 10 points are there. So this is correct. Right, now we can answer any question. So precision, they are saying precision we need to calculate, right? So precision is nothing but how precise you are. Like if you're predicting, let's say 3, how many positive value you are predicting? So 3 plus 0, 3. And how many are like correct positive, or you can say true positive? So 3. So 3 divided by 3 is nothing but 1. So precision is 1. So either option B or option D, right? Now recall how, like out of all the positive points, how many I'm able to get. So how many total positive I have? 3 plus 3 is nothing but 6. And how many I'm able to get? 3 only. So 3 by 6.5. So again B or D. Let's calculate the precision, this recall F1 score. So F1 score is nothing but 2 p divided by p plus r, right? Or you can use this like weird equation also, but 2 p divided by 1 p plus r is like easy to, you can remember, and then you will get the answer is 0.667. Correct. So option B is correct. So I hope like there are like multiple questions like this tomorrow. Okay. This was googly actually. They put it in medium. Yes, it was like it was not easy if you don't understand this formula, this reachability distance formula. Then like there are high chances of making mistake here. uh, yes, this was out of syllabus. Like when the alpha would be, you can say very very high, it would be 1 by this lambda or gamma, like kind of symbol is there na. So if it is k alpha, it's if it's multinomial na. Mostly in NLP we use this multinomial formula, right? Not that simple one, that simple classification, because in NLP you cannot just take one feature because every word is feature. So you need to count the all words. So in that case, if the alpha is very very high, you will get 1 divided by gamma. And it is not if gamma equal to, if it is just 2 class, then it would be zero point 0.5. right? So it would be 1 by gamma. So this C was incorrect. To tends towards point 0.5, 0.5, and they were saying option C is correct, but it is not. Okay. Yes, this one. So this can be answered like in two ways, but option D can be also true. So one way is like they are saying unit circle. So what they are saying is given four vectors x1, x2, x3, x4 such that they lie on a unit circle. So on unit circle, I have x1, x2, x3, x4 like this from origin basically, right? At the origin in the same clockwise order. So if I have x1 here, then x2 here, then x3 here, and x4 here like this. The Euclidean distance between x1 and x2 are given. X2 and x3 is also given 1.075 and 1 unit. X3 is perpendicular to x4. So this theta is given, or you can say 90 degrees given. So now they are asking what is the approximate, or you can say rounded to 1 decimal place, Euclidean distance between x1 and x4. So they are asking about this distance. So how can we find that? So in exam, I don't like. I didn't get like we need to use this formula Euclidean distance and cosine distance. So the how you can answer is like how did I answer this? So this is like a unit circle, right? So the diameter would be 2. So you cannot have the distance like greater than 2. So option B, A and B are definitely incorrect. So either C is correct, either D is correct. But why one would do like this kind of you can say mathematics and setting up all this thing if D is correct, right? It can be, but 50-50 chance. So 50-50 is better than 1 by 4, 1 by 4, right? So option C, you can mark that, but let's see like how to solve that. So this distance is known, right? X1 to x2, Euclidean distance. So you can calculate this angle. What is the problem? So you can calculate this angle, right? X2 and x3, this distance is not. So you can calculate this angle. 65 or 60, it is coming something like that. I just solved that before the session. So and you know this is 90. So this angle is now trivial. This angle, whatever the angle you get, let's say you get angle theta 120, 145 or something like that. Now this distance you can find out how. We know this Euclidean square is nothing but 2 into cos distance, or I don't remember that way. I remember 1 minus cos theta, cosine similarity, or 1 minus cos theta you can say. So it's nothing but cos distance. So theta we know, cos theta we know, 1 minus we know, multiplied by 2 we know. So you can calculate the Euclidean distance by just taking the square root, right? So let's try to solve that. Yes. So x1 and x2, this distance is given 1.075. So Euclidean distance between x1 and x2 square is nothing but 2 into 1 minus cos theta. And to just not get confused, I just wrote x1 x2. That means theta between x1 and x2. So by putting Euclidean distance is given 1.075, you can calculate the cos theta. Actually, I should have written theta, not cos theta. Theta is nothing but 65 degree. Here also I have made mistake. Right? So theta we know 65 degree. Again, same formula for this thing. X2 and x3. The distance is given 1. So we can calculate the angle 60 degree. Right? Now, they have given that x3 and x4 are perpendicular to each other. So this degree 90 degrees given. The angle between x3 and x4 is given similarly. Simple, right? Now they are asking what is the distance, Euclidean distance between x1 and x4. So the Euclidean distance between x1 and x4 is nothing but 2 minus cos theta x1 and x4. And this theta between x1 and x4 can be found out by 360 minus sum of all this angle. 360 minus sum of all this angle. So 145 I am getting. So if you put this theta equal to 145, you get this thing. Euclidean distance square 3.64. Just take square root. It would be nearly equal to 1.9. Right? So they can and I like how they construct, or you can say form this kind of a question, right? Any questions, guys? Any doubt? Yeah, I just missed that. Yes. Okay, I will take it as good to go. Let's go to question number 24. Okay, for Gini impurity, again I missed this. I let me see if I wrote this or not. I must have missed that. Mid sem 3. Yes, I again missed that. Okay, so consider a uniform discrete distribution for a random variable k, which can take p different value n1, n2, n3 up to np. What will be the Gini impurity value of k? So in mock 1, I guess in mock 1 or mock 2, I guess in mock 1 they ask like for uniform discrete distribution, what is the what do you call it, entropy basically, right, of that random variable. But here we need to find out the Gini impurity. So the idea is very clear. We need to just find out. See, this is uniform, or you can say discrete distribution, right? So the probability value for each variable we can calculate for n1, n2 up to np we have. Now for all this, the probability would be similar, right? So the probability for n1, n2, n3 up to np, this is looking right b, is nothing but the similar value, and it would be nothing but 1 by p. Any doubt? Because I have total p, you can say, observation, and all of are having the same probability. So the probability for each observation would be 1 by p. Correct? Same as like throwing a dice. If you have 6 observation, or you can say 6 number, probability for each number would be 1 by 6, like that. Now I know the probability value. So how tough it is to calculate the Gini impurity? Nothing fancy, right? So Gini impurity is defined something like this: 1 minus p1 square minus p2 square minus p3 square minus p4 square, like that. Correct? So 1 minus 1 by p square minus, so let's take the minus out. So 1 by p square plus 1 by p square plus 1 by p square, p times I am taking. So I can multiply this by p and p will cancel out. So I get this answer 1 minus 1 by p, or you can say p minus 1 divided by p, option D. Right? For entropy, it was coming log p if I'm not wrong. Okay, any doubt guys in this thing? Because now like they given like of both the distribution which is possible, like for Gini impurity and entropy both, right? So you can expect like one of the question, because like around 30% 30 or 40% are from these three papers only, right? So let's have some action now. Now everything okay. So, question number 25, very good question. This type of question yesterday we solved. There they had given W1 and W2, and we need to find out the proper value, or you can say the best value of W0. Now, what they have done is consider the data points and their corresponding target variable shown below. So, F1 and F2, I have the target variable are 0, 1, 1. Right, given that the best logistic regression equation is of the form y equal to sigmoid wx plus w0, right, where w equal to point minus 0.52 and w2, we don't know what is the value of w2, and w0, or you can say bias term or intercept term, is 0.45. What is the best value of w2 among the four values given below? So how logistic regression works is, so we know this y, right, these are the ground truth. We will calculate the y prediction, right, and y prediction is nothing but sigmoid of this wtx plus wtx, or w dot x, I can say, plus b, right. So this is nothing but my probability. So given w is nothing but w1 w2, yeah, for this you can say two dimensional weight vector, multiplied by x1 x2, so w1 x1 plus w2 x2 plus b. So whatever the answer I get, I need to just put let's say is z. So sigmoid of z I will take. So this will give me the value between 0 to 1. So it's nothing but the probability of class 1, right? Positive class. Now I know all the probability in this y hat, whatever the answer I get. Now I can calculate the log loss, right? Because in logistic regression we use the log loss. So I will calculate this log loss for each the observation. We have three observations only, right? Three inputs, right? So I can calculate the log loss and find out like how much loss I am taking. So we will do this, you can say majduri, or you can say this kind of a thing for all the value of W2. Like four value we have, right? 1, minus 1, 2, and minus 2. So first we will take W2 equal to 1. Then we will calculate how much loss we are making. Then we will take W2 equal to minus 1. Then we will see how much loss we are making. Similarly for 2 and minus 2. So whoever is giving me the, you can say, at least loss, right, minimum loss, that is the best value of W2, right? So if we do this by calculator, definitely it will take so much of time. How much? 9 minutes, right? Around 9 to 10 minutes. But if they allow the Excel, then it's fine, right? Just we need to write the formula once and then you can drag and drop. So let's jump onto Excel. Question number 25, they are saying best value of W2. Huh. Right, so they have given this 4 value, and f1 and f2 and y are given. So first what I am doing is I am taking w2 equal to 1, then minus 1, 2 and minus 2, and predicting the probability, right? So these are nothing but my probability value. Just a second. Now it looks beautiful, right? So these all are the probability value. So if you see this 1 divided by 1 plus e to the power minus w1 x1 plus w2 x2 plus w0. So w0 is given here, 0.45. Don't miss that. Right, so these are the probability that if I take w1 equal to 0.52 and w2 equal to 1, so these are the probability. If you take w2 equal to minus 1, then 2 and minus 2, so on and so forth, I found out all the probability, right? Now let's see, like which is the good, you can say, like who is the good, what is the best choice of W2. So how can we do that? First calculate the last one. That means this model with W2 equal to 1, how much loss it is making. So if it is 0, y equal to 0, then we take log of 1 minus p, otherwise minus log of p, right? So I have written this log loss formula here using the if condition. Uh, Correct. So these are the loss, and this is the total loss for the W2 equal to 1. This is the total loss for W2 equal to minus 1. Similarly for 2 and minus 2. So if you observe, the minimum loss is occurring when I take W2 equal to 2 at 0.63. The next would be 1, then minus 1 and minus 2. Correct. So the best choice of W2 is nothing but 2. Correct. Any questions, guys? Any doubt? Okay, I will take it as good to go. Let's jump on to the next question. Right. So yesterday we saw this kind of question when W0 was missing. Right. So let me show that question also so that you can relate, and we can predict like which type of question is this. Yes, this one. So they had given this W1 and W2 was given, and we need to find out the best choice of W0. So similarly, we did the same thing, calculated this predicted value when W0 equal to minus 0.22, then 0.15, then third value, fourth value, right? Then first we calculated this y predict. This has nothing to do with like question. I don't know like what I was doing. Then we calculate the log loss, and the minimum loss was occurring here, 0.755, right? Neck to neck competition is there, but D is the correct answer. Minimum loss, right? So they can like miss W1 maybe tomorrow. Let's see, who knows, right? Okay. And this method is also okay. I don't know like why they are using this kind of a method. They are taking the log loss formula, then putting everything. Just a second. Right, and then they formulate the loss function, and then they use something minimization formula. I don't know what is that. And same amount of effort we need to apply here also. So actually more amount of effort. So better to do like go with the roots, right? What we know, take the y prediction, calculate the log loss, whichever is giving the minimum loss, that's the best choice. Okay. Okay. Star question, or we have like the maximum number of questions from naive bias. So here they are asking for the ratio, right? And we know it better, right? Like finding the ratio is a better approach in naive bias than calculating the probability for y equal to 0 and y equal to 1. Correct, because so many terms will cancel out. So you will find the ratio like faster than calculating this probability one by one. So let's take this question 26. So we have some data set. Cool. And the query points are there. What if it is big, hot, and slow? If small, cold, and slow. So what is the predicted value of y? So they are not asking the answer, they are asking the ratio. So P of C1 given x10 and P of C0 given x10. So we need to find out this ratio. So if option A is correct or option B is correct, like that. Again, for C and D, the ratio is similar. For x11, what is the ratio of it being the class 1 and x11 being the class 0, right? So let's see like how we can solve that. So yesterday we just saw, so let's try to solve it from the scratch. So let's take this x10 now. So it's nothing but big, hot, and slow, right? So first we will put what is the probability for 1 and what is the probability for 0, right? 1 and 0 they are asking. Okay. So whenever I am having 1 here, so what is the prior probability? First we will write that, right? So prior probability of 1 is 1, 2, 3, 4, 5. So 5 by 9. And here I have 1, 2, 3, 4. 4 by 9. So 9 and 9 will cancel out, right? Again, for this, the total number of 1 would be 5 only, right? 5 only. So I can directly write 5 raised to 3 here, right? Because it would be 5 here, 5 here, 5 here. Right now we are master, right? We have done this like so many times, so we can take some shortcuts. If you have time, don't use shortcuts because it hurts a lot when it backfire, right? Now I just need to just focus on the count directly because everything is taken care, right? So out of 5, how many you can say for 1, how many big I have? So 1, then 2, 2 only, right? So 2, and how many are there? 1, 2, 3, 4, 5. So 3 would be 0. Correct. Let's take this hot. So hot 1, 2, 3, 4, and 5. So out of 5, I have 1, 2, and 3, 1. 3 where y equal to 1 and raised 2 would be 0. So we need to make the count also once, right? So if you are calculating probability one by one, then you will be going for 0 and count how many hot I have, like that, right? So let's take for slow. So how many slow I have? 1, 2, 3, and 4. And how many ones are there? 1, 1. So 2, 2. Right? Now they are asking for the ratio. So this 2 and 2, 4 will cancel out with this. So here I will left with 4 square. And here, sorry, sorry, 5 square, right? So 4 so 64 divided by 25. So the answer would be somewhere around this. Just a second, let me open that notebook. Huh. For x10, it's 16 divided by 25. Right, so if you calculate 16 divided by 25, the answer would be nearly equal to 6.64 or 0.63, like that. 0.053 then 0.083. I know this is not exactly the correct answer because they are taking the, you can say, they are making the rounding error twice. They are rounding it here also and they are rounding it here also, right? So that's why they are getting this answer. But if you take the in calculator, if you put 0.053 divided by 0.083, actually 53 divided by 83, it would be nearly equal to 16 divided by 25, right? So this way we can find out the ratio or answer. And if they ask for the label, what would be the label for x10? Anyone? Let's see if you remember from yesterday.
0.
0, because the ratio
Yeah,
is
less
less than
than
1.
1. Yeah.
The ratio is less than 1. Numerator is higher value. So the class of x10 would be 0. So this saves like lot of time, right? Because we need to now don't need to calculate this probability and this probability and then find out like which probability is higher. From this fraction also we can say that this probability of 0 would be higher. We have 25 here, we have 16 here. So directly the class would be 0. Right, same thing we can do for x11 also, small, cold, and slow. 5 by 4, you can directly write 5 cube here and 4 cube here, right? Because we are calculating the probability of this x11 given small of small given it is y equal to 0. So in denominator it would be 4 only, right, for all these three. So directly you can write 4 cube here, right? Then just put the count as we saw like for x10, correct? And here it would be 48 divided by 25. So the class would be nothing but 1, right? Because this ratio is greater than 1. So probability of x11 or you can say y equal to 1 given x11 would be higher, right, than given y equal to 0, right? And this ratio would be roughly equal to 53 divided by 28, or you can say 0.053 jam 0.028. Any doubt, guys? Because just remember that and practice that, because otherwise you will make mistake like this, because I completely overlooked this 5 and 4 value. I just put the number. I don't know like how, which mistake I made, but yes, it happens in exam sometimes. You don't make like any error in practice, but in exam there are high chances of making error. Uh, any questions, guys, in naive bias or overall, like how to tackle these naive bias questions? Because in this question, we actually practice both the scenario, simple ratio, and find out the label itself. Any questions, guys? Because this would be the last, you can say, revision session. So, do you have any still, you can say, doubt in this naive bias question from Mok 1, Mok 2 also?
Mayur,
Yes.
I got it till the ratio part,
Uh
but
huh.
how it is less than 1, right, for the first one?
Hmm.
How did it come up to 0.053? I didn't understand that part.
Uh huh.
16 by 25
Uh
is less than 1.
huh.
So, 1 second.
So is less than one, na? So see, when it is less than one, if this ratio is less than one, that means the probability, or you can say the answer of this thing denominator would be greater than this, right?
Yes,
And
yes.
it is, see, the answer of this would be 0.083, and answer of this denominator numerator would be 0.053. So whichever, like, who has the higher probability? This one only, right?
Yes.
And it is clear here from 16 raised
Yeah.
to 16 to 25 ratio.
So it is actually
Class 0.
no, no, no. I mean to say, you cancelling out what you have done,
Uh-huh.
the mathematical this thing. I mean, the
Uh,
numerical. I'm trying to understand the numerical calculations. What that is. 16 by 25 is from 0.63 or something. That is the odd
see,
ratio, right?
correct, correct. You can say this odd ratio. You cannot say the probability of y
Yes.
equal to 1 is 0.16 and probability
Yes.
of
Yes.
0 is 0. No, no, you cannot say that.
Yeah. Yeah.
Right? Because this ratio can be written in this way also. Right?
Yeah. Yes.
And theoretically, there are infinite way to write this ratio. Right? So this value doesn't hold like any true for the actual probability of y equal to 1 given extent, or y equal to 0 given extent. Correct?
Right.
This is, you can
Yeah.
say, this simple kind of a aptitude trick. Right?
Mm.
Nothing fancier, right? Because this doesn't hold true like 0.48 and 0.25. No.
Yes.
Yes, that's correct, because okay. Any more doubt, guys? So, or we can jump on to next question. Okay, this is pure Mazduri question, nothing fancy here. We need to calculate this mean absolute error and R2 also. In calculator, I just calculate for mean absolute error, and then I thought like if the MA is better, M2 would be also better. But no, it is not. It was not the case. That's why I got this wrong. Because like this is daunting if you calculate, if you want to calculate this in the
Mayur,
calculator.
actually, I thought in that way. There is a one that tricky thing is what when you that because of this zero value, x having a zero value now.
Uh,
Because of this only things has been basically wrong.
uh,
Otherwise, both matrix will give the same answer.
uh. But this is the special case basically.
Yes, yes, yes. I calculated for one. In fact, after this, I left it out. I will not do any calculation. I I did till y square y critical square and I can't do more calculation.
Correct. So I hope they provide like even Python, simple Python or Excel, right? So then it would be easy. So let's do that Mazduri once. So what they've given is x and y value are given data set, and we have two model. M1 slope is 0.2. Even the slope was not very, you can say, cute, that 1 and 2, 3 and 4 like that. Then we can do it like orally. But for this, we need to use the calculator. How will do like 2.05 multiplied by 0.65? right? M2 slope is like 0.65, crazy, intercept -1. Okay, now we need to calculate two thing, R2 score, or coefficient of determinant or determination. What is that? COD. And this MA, mean absolute error. So MA is nothing but mean absolute error. So we need to calculate all the error absolute of y minus y predicted and get the sum. And for R2 we need to calculate sum as residual, as total, and then calculate the R2. So let's see. In mid 3 would be there. Huh. So these all calculation we need to do on paper, guys. Right? So first we need to calculate the y predict. So y predict is nothing but mx plus c. So m is given zero point 0.2, so zero point 0.2 multiplied by x plus c, slope 1.3. Not slope, intercept, sorry. Right? Or bias term. So that's how we calculate for one term. And yes, you heard me right. We need to do this 10 times. Right? So around 2 minutes gone. Now we need to do this exercise for M2 also. Mx plus c, 0.65 into multiplied by this x value plus c. Plus is nothing but -1, or you can say plus -1. Right? Then you can do this for 10 times. Rate, right? So you calculate all the y predicted value. Now absolute error, you can directly calculate the absolute difference between y and y predicted is nothing but my absolute error. Similarly, you need to do for M1 and M2. You take the sum of all absolute errors, so this is nothing but average of this absolute error, so it's nothing but MAE, mean absolute error. Similarly for M2, so from this it is clear that mean absolute error of M2 is higher than M1, right? So some of the option will cancel out. Now we need to calculate R2 score. So R2 is nothing but 1 minus SS residual divided by SS total. So basically we are comparing our error, residual error, with the average model. Right? So SS total is nothing but y minus y average. So if we are using average model, then the predicted value would be the average value of y. Every time it will predict 1.9720. Right? So what error we are making? It's nothing but the sum squared total error. So sum squared. So we need to take the square. Yi minus y bar. I'm just using this dollar, so it doesn't change. Then take the square. So you calculate all the SS total, take the summation. And for SS residual, it's simple. Yi minus y predicted or y hat square. Or you can take otherwise also. Y predicted minus y square. Right? So you get some SS residual, and then you do this for M2, but for this M2 SS total would be similar, right? Because this y is not changing, so y bar would be same, right? So SS total would be similar. You just need to calculate SS residual. Now this SS residual is smaller than this, right? So you don't need to calculate actually R2. From this value you can basically say the R2, or you can say R2 score for model 2 would be better, because it is making less error. See, 6.41, and here I have 8.39. So it is also justified by, if you calculate R2, you will get 66% or 0.66 for M2 and 0.56 for M1. So it is making more absolute error. Still R2 is better. Here it is making less absolute error, but R2 is, like you can say, comparatively bad with like if you compare to M2. Right? So this was the I just calculated this absolute error, and I say okay, this model is worst, right? It is making higher error, absolute error. So R2 would be, you can say, bad also. So M1 is better. So I go with that intuition, and I got it wrong, completely wrong. Right? So M2 has a better R2 score, and MAE of M1 is lesser. Right? Uh, Next question. So this is the repetition from mock paper. Like nothing was changed. Even single digit was, I guess, not changed. Right? Nothing was changed like in this question. So you can apply the same logic, or you can watch the previous video if you still have the doubt. Right? Let's take next one. Yeah, this was the googly. This was the googlier one. Or we discussed this. You can say dual form, not in very detail. Sir just wrote the formula and we just move on, right? So I thought it won't be there. Even in my notes, I didn't write this equation also. But how I got it right is the another like other story. So a linear SVM model is trained on the dataset below. So I thought like, okay, linear SVM good, but this alpha was given. So her life was, you can say, f star star star. It was found that the best model is one of the whose hyperplane passes through the origin, so W0 is 0 or bias B equal to 0, and whose Lagrangian multiplier corresponding to column alpha. So alpha is nothing but my Lagrangian multiplier alpha I am taking. In the dual form, we use this formula to calculate, or you can say the predict the class, right? So if it is positive, then positive, negative, then negative. So see here they have written like this. So if the sign of this calculation, if you are getting the positive value, so you can get crazy number like this 6, 49, 104 like that. But if it is positive, then positive class. If it's negative, then negative class. As simple as that, right? So it's couple of, you can say, multiplication, nothing fancy. So what would be the class is predicted by the SVM model for the following query data points. So we have 3 points and we need to find out the class, right? So the hack that I used to answer this, because I didn't know like even simple formula, like I didn't know like what the formula is this. So what I did is like I had like plenty of time left. So what I did is I just draw a rough graph paper, rough graph, right, and put all these point 2, 3, 2, 1, 0.54, right, and the class are given, so crosses and 0, right, and then I try to put this point 1 3 minus 1 2 and minus 2 1, right. So there won't be like many outlier because this is very small data set, right, and luckily I was getting all these 3 points in the positive half, near to positive point basically, right. So you can answer that way also, but don't go that way, just remember this formula, it's very simple. So what that formula is saying, so alpha I, that's fine, for each point I have alpha I, yi is also there, right, 1 1 1 minus 1 minus 1 minus 1, okay. Xi transpose x. So what is Xi transpose x? So here they should have written x cube for, you can say, ultimate, you can say, this clarity. So Xi transpose into x cube. So this is nothing but my x cube query point 1 3. If I'm taking the query point 1 3, then what I'll do, I will take 1 3 1 3. Then I will take the dot product between xi, that is nothing but f1 f2 2.2 3.2 and 1 3. Right, then I, whatever the answer I get, I will multiply it by yi, so 1 multiplied by alpha, whatever the answer I get, plus b. So it's passing through origin, so plus 0 basically. So whatever the answer I get, I will note it down. Similar practice, similar way, or similar mazduri I will do for 1 2 3 4 5, and then take the summation of all. Similarly I will do for, if the answer is positive, it's positive point. For minus 1 and 2 I will do the same, minus 2 and 1 I will do the same. Right, so let's jump into this thing. What do you call that? Google Sheet, and let's see. Have I solved that? Here we have. Right, so f1, f2, y and alpha are given. F1, f2, y and alpha are given. For P1, 1, 3, I just need to calculate this thing. What do you call that? Yi alpha I. So this is yi into alpha I, alpha into y, and then take the dot product between x and x cube. So x cube is 1 3. So if you take dot product between these two, it would be nothing but 2.2 multiplied by 1 plus 3.2 multiplied by 3.2 multiplied by, what is that, 3, correct. So I will get some answer. Similarly for all the point, if I take summation of all, I get 104. So it's greater than 0 positive, so it's 1. Similar way I will do for p2. Take the dot product between this 2 2 3 2 3.2 and minus 1 2, multiply by y multiplied by alpha. Here we have everything in multiplication, right, whatever the answer you get, take the summation, so on and so forth for p3 also. So we are getting 1 1 1, right. Any doubt guys? So the thing, or you can say, the hardest part in this question is nothing but to remember the formula, right, then everything is simple. Correct. Any doubt, guys? Any doubt? And if you are planning to use the Python, then I will recommend like you like write this code like on your own, because in exam, like due to anxiety or anything, it is tough to like debug the code basically, right? So if you're planning to write the Python code, then definitely practice it twice or thrice.
Yeah, Mayur, I think we should discuss with them while they are giving the solution. They are writing the code. Okay,
Correct.
but why they are not trying to us to write a code?
Nah, they said nah, they even like they sir agreed now if there are like tedious calculation, then they will allow this code or Excel, right? So I will prefer Excel over code, because like in exam you can say condition, it is tough to debug a code, right? With the cool mind you can debug a code, but if the mind is not cool, debugging a code is the hardest part actually.
Actually, it's a subjective call.
I can't debug like if I'm in high tension. Okay,
But
I like my heart like I am a hardcore engineer, so literally I drew this like all the point on the chart and got the answer, and literally all three are falling in the positive side.
at my part, after that having a linear regression jugglery, na, I basically left the paper as it is only. I thought I will not do it. When the marks will come, na.
I will see. Yes.
तो फिर तो मैंने
Correct.
जय माता जी किया था लास्ट में कुछ किया ही नहीं मैंने. I was knowing all the formula, but I have not done it anything.
हाँ, correct. बिकॉज कैलकुलेटर में करना इज लाइक अरे बाप रे, छोड़ो इससे अच्छा तो आई नो कैसे करना है, ठीक है. Okay, guys. So let's take the last one for today. It is cool. Like generally अभी 11:30 होते हैं, but generally today it's just 10:30, so it's good. Let's see. Given that we use the decision tree model for the data set below, G1, G2, G3 represent the gene impurities products produced when F1 and F2 and F3, F1, F2 and F3 are used for the first split respectively. Okay, so we have this whole data set Y, right? Then which of the following options are correct? Feel free to use a calculator. Okay, we need to simply calculate the gene impurity. All right. So yesterday we saw similar question, I believe. So let's see like how we can solve this. So we need to take the variables one by one, f1, f2, and f3, or you can say the features one by one, and see like how much gene impurity or how much impure they are. Right? If I use that for the split. So if I use f1 for a split, I have just two options, 0 and 1. Right? So for 0, I will have at that node I will have three value, bad, good, and bad. So two bad and one good. So we can calculate the Gini impurity 1 by 1 minus 2 by 3 square minus 1 by 3 square. So that would be the Gini impurity for node 0. Right? So if I use F1, there are two nodes only for 0 and for 1. So at 0, I have like how many bad I have? 2. And how many good I have? 1. So Gini impurity would be nothing but 1 minus probability of bad 2 by 3 square, probability of good square, probability of good square, so 1 by 3 square. So whatever the Gini impurity I will get, let's say I call it at x, x0. And here I get some Gini impurity x1. Then I need to take the weighted average basically, right? Because if we are having these nodes, different nodes, we need to take the weighted average. Why weighted average is important? Because I have just three data point here and I have six data point here, 1 2 3 4 5 6, right? So whatever the impurity I am making here, it should be given higher weightage, right? If I cannot simply take x1 plus x0 plus x1 divided by 2, no, I need to take weighted average. So how to take the weighted average? So Gini impurity we have calculated x0 and x1, so it would be nothing but 3 by 9, or you can say probability of node, or n 6 by 9. So if you take this, it would be nothing but my g1. Any questions guys in this formula? Because I am now going to excel, right? So now I guess the idea is clear. Just see like for 0, how many you can say variable I have, bad, good, and bad. Calculate the Gini impurity of that node. Calculate Gini impurity of the other node. Take the weighted average. So it would be nothing but my Gini impurity if I use f1 as this thing, splitting purpose. Correct. And the same Masduri we need to do for f2, f3, f1, f2, and f3 both. Right. So this is the correct one. Yes. So for f1, I have just two 1 and 0. Let's take for f2. Let's see for f2 what is happening. So for f2, I have three. You can say if I use f2 as what you call that split. then I will have three answer: red, green, and blue. So for red, I need to calculate the Gini impurity. For if it is red, how many bad I have? Two. How many good I have? Zero. And what is the total? You can say bad and good, two. So you can directly write zero because say this is pure node, right? It is no mixture. There is no mixture. Two bad and zero good. So no mixture. Zero zero. And yesterday, like in previous, you can say mock 2, I had make some mistake in taking the weighted entropy, so I corrected that. So sorry for that, but please say this again if you like didn't get that, right? So I made some mistake by while calculating this, making this basically this equation, right? uh, So for red, I calculated this Gini impurity. For green, we can calculate that. So for green, I have three bad, one, two, and three, and good is one. So it is impure node, right? Because it's not clear if it is bad or good. So impurity is nothing but 0.3750, and this is nothing but the weighted Gini, right? 8 and divided by 9. So 4 divided by 9 into the whatever the impurity I am getting, right? So you calculate it for red, green, and blue, take the summation, so you get this Gini impurity for f2, right? So it is called g2, they are saying it is g2. So g1, g2, g3, you know. So g1 is what is g2 is the like smallest, and g1 is the highest, right? So g2 is the smallest, g1 is the highest, correct? Any questions, guys? Any doubt in the Gini impurity? For the practice, if you want the question, you can calculate the entropy, right? Just for fun.
Mayur,
Yes.
one thing that this is for classification, right?
Uh-huh.
If we supposed to create a decision tree for regression case, right? In that case, we will be using that sum of squares of error, right? To decide
Huh.
which split is the best. Okay. So in that
Okay.
case, I think we will not take the weightage that we are doing. No weightage sum after calculating the child, every child separately, and then we are combining on weighted average, right? In case of classification or the thing, but there I think we will not do like this way.
Okay. Correct.
Why
Then
don't you do
we will
this?
take simple average of error, right? Because there it doesn't make sense to take the weighted average. Correct?
No, no, not average also. We will combine as it is only because somewhere I
Total
think
error. Okay, okay, okay. Yes.
uh,
Sum of
uh,
error, huh?
yes.
Yeah,
I mean,
that
some
makes
of it
sense.
see that one node is that is split let's say into two nodes.
Mm-hmm.
Okay. So in case of classification, what we are doing basically we are after calculating this child
Huh.
separately, we are taking the weightage average, right?
For regression, what you're doing, you're saying? Sorry.
For regression, I think we will not do the weightage the sum that we
Huh.
will just directly sum it up only.
Yes, that would be total error that we are making. That makes
Yes, yes.
sense. But in video, I guess they said like we decide on one parameter that how much you can say mean absolute error, or you can say square error we are making at
No, no, no,
parent
that's
node,
okay.
and
That's okay.
huh,
My question, I think you're not understanding my question. My question is, let's say node A is
huh,
divided into B and C. Let's say
huh,
suppose, okay. Now,
correct.
in case of classification, what we are doing, we are calculating for B separately, calculating C separately, and then we are
Huh,
combining on weighted matrix, right? How many the points in A, how many points in B, how many points in C, right?
correct, correct.
But in the case of that error, we not supposed to do all those things. We will just calculate for B, whatever error we calculate the error for C, and then we will just sum up. That's it.
Yes, yes, yes. That makes sense. Yes. Huh.
Because I read somewhere that since the SSE itself basically having this formula, na, mean square error,
Hmm.
weightage already there, already done.
Hmm. Correct, correct. Yes, that makes sense. Yes, and that parameter we can choose freely, right? We can choose
Uh,
ME.
And why I am basically raising this issue because somewhere I don't know basically I'm whatever the best I can recall Srikanth has just conveyed a different way. Just
Hmm.
wait is thing here also.
Huh.
Yeah, that's why I want to cross check with you that whether Srikanth I think somewhere basically he conveyed in that way.
Okay.
So we have to check it.
नहीं हाँ actually that makes sense ना if you are taking let's say R2 score, so definitely you don't need to take the average of the child node. Yes, that makes sense. Right, because definitely we need to reduce the error one by one, or you can say at the next level. So we should take actually the sum of that, not the average of that. Yes, that makes sense.
Okay, thank you, Mayur.
Huh. And now I solve this mystery. If the caps lock is on, I get just blue color. If caps lock is off, I get three color. Okay.
Mayur, I think you start using this OneNote. It's the best app I
Yeah,
can
I
see.
understand, but I'm writing using mouse, so that's why I don't have that
In fact,
notebook and pen.
nowadays that no need to purchase the pen tablet. The mouse itself is coming in the form of pen itself.
Great.
So this is I yes I was checking that's 2,000 rupees only.
Mm-hmm.
So you can basically what they have done it. See, this is something like that. Someone having a mother